Less than 100 is basically just a few more integrals to add to, you know, how do we work them? What do we know? What do we have memorized? A few more trig integrals. Integrals of powers of tangent and cotangent, and just in general, integrals of secant and cosecant. Now, the helpful hint to remember here, some information involving tangent and cotangent. Tangent squared and cotangent squared are both involved in some Pythagorean identities. Tangent squared plus 1 is equal to secant squared x, and cotangent squared x plus 1 is equal to cosecant squared x. So that's kind of your hint up there as you remember these. Hint of what we're going to be doing here. So, example 1 asks us to integrate tangent squared x dx. Well, I can tell you the derivative of tangent. I can't tell you the integral of tangent off the top of my head. Okay? So, tangent squared x then, a little bit different. What do you guess we're going to do based on the remember comment up there? Okay, take tangent squared, and what can tangent squared replace with? Secant squared x minus 1. So let's start there. So the integral of tangent squared x is going to become the integral of secant squared x minus 1 times dx. Well,
I think we can integrate that.
Think we can integrate that? So officially, not that you'd have to do this necessarily, but officially keep in mind two things can be subtracted, can be rewritten as two separate integrals, right? So we can officially think of this as the integral of secant squared x dx minus the integral of 1 dx. Okay, you've got to get your trig integral derivative brains working here. Secant squared, the integral of secant squared x. No? Secant squared, so we're thinking integrals. Well, secant squared x is the derivative of something we know. So the derivative of tangent is secant squared. So the integral of secant squared is tangent x. Are you following there? I have to get your brains in the right places, right? Thinking about all these connections. So you're expecting to know the derivative of tangent is secant squared x. So ideally, when you see a secant squared x, you're trying to integrate it, we know that just needs to become tangent x. Minus the integral of 1 x. And then Ethan's got it covered for us. Don't forget your plus c. Okay. That's all on that one. Again, do you see what I mean? It's using information you already know, right? You had to tie in a Pythagorean identity. You had to tie in just the fact that you should know the integral of secant squared x. Okay, so when it's just a tangent squared Pythagorean identity to replace. Example 2. We're moving up in powers here. Example 2 is a tangent cubed x. Well, thoughts on some of based on some of the other things we've sometimes done.
Well, we could break it up into tangent squared and tangent.
Okay. So let's break this up. Let's see how they do this in my notes. Into, and this one is going to have more to write, sorry to say. But we're going to break this up into integral of tangent squared x times tangent x times dx. Use the skill from the first one. What can tangent squared x be replaced with? Secant squared x minus 1. Now I should have written those in the other. I'm going to flip-flop my pieces just because I'd prefer to have this plain tangent out front before I put these parentheses. So I'm going to write this as integral of tangent x times, well, tangent squared x I'm going to replace with secant squared x minus 1 times dx. What can I do with that tangent? I can distribute. As I distribute, I'm also going to, since there's subtraction here, I'm going to go ahead and break it up into two integrals, if you will. So what's tangent times secant squared? And that is tangent x secant squared x dx minus the integral 1 times tangent, so tangent x dx. Okay, two different integrals to deal with. First one we have is tangent secant squared x dx.
Well, that looks like some chain rule going on, right?
It is. And some of you are going to be able to see this just as is, or maybe with a little, preview, you'll be able to see it as is. I'm going to use a u substitution to help you fully see it in case you need that. Again, it's one of those things, when we do it, we don't always need that. But Ross says he sees a little chain rule going on here. What do I want to make u? Right, we're going to make u tangent. So I'm going to do a side step over here. If u is tangent, what is du? Right, so du is secant squared x dx, because the derivative of tangent is secant squared x. Now, I don't really have room to write it here, but think about I'll write it over here. The integral, if u is tangent x, right, here's u, and then secant squared x dx is du. So what's the integral of u du? Yeah. That's 1/2 u to the second, except ours isn't u for our final answer. We're going to go back and say 1/2. Ooh, how much am I going to run in? I think I can make this work here. I don't want to go really down into the next problem because I need room on the next problem too. Okay, so that first piece is 1/2 tangent squared x. Because you add 1 to the power and divide by the new power, right? Mm-hmm. Minus. Okay. Integral of tangent. Do we know it? You don't. That's part of what we're doing today. Okay, so guess what? Side note. We're going to try and integrate tangent x dx. We don't know the integral of tangent. U substitution doesn't really do me any good because I don't see any, anything else in there. What do you know about tangent as a fraction of some other functions? Okay, so that's the direction we're going to go with this, is that tangent is sine x over cosine x. So we're going to integrate this as the integral of sine x over cosine x dx. I'm going to use, again, another u substitution to help you see this. Again, as you get better with this, it's not necessarily that you have to use u substitution on this one. Some of you might look at this after the fact and be like, oh, I didn't really need u substitution with that. I can see that. Others of you are saying, oh my gosh, how can you do that without u substitution? So, I never know where people are at. So I always at least show u substitution. Now, Thoughts? If I say I'm going to use u substitution on what I want u to be here.
Cosine.
Cosine because it's in the denominator. So process through with me. If u is cosine, picking cosine because it's in the denominator, well, what's du?
Sin x dx.
What'd you say?
Negative sin x dx.
Okay, I wasn't sure if you said the negative
I
or
didn't
not.
say it the first time. But
Okay, and that's why I asked for the repeat, and then you started thinking, so I figured you might not have said it. So the derivative of cosine is negative sine, so this is negative sine x dx. Oh, coincidence that sine is in the numerator? Not really.
It's almost like math works.
Yeah. So we are integrating here. Cosine's in the denominator, right? Sine x dx, there's sine x dx, and that's a du. If I put this as a 1, the only thing we don't have covered is the fact that there is a negative. Does that work for you? Okay. Do you see it? So what is the integral? Well, it's a negative integral of 1 over u.
Negative natural log.
Okay.
Which in this case is tangent x.
Right. No, not tangent. U is not tangent. U is cosine. So negative natural log of cosine x. Notice I'm using the absolute value this time. Because cosine, it oscillates, doesn't it? It has positive values, it has negative values. So I'm using the absolute value there. Now, I am perfectly fine with negative natural log of cosine x. And so what I just, do I want to say prove to you, is that the integral of tangent x is, one way to express it, negative natural log of cosine x. However, I need to say it at this point as well, so I don't forget later. There's an or option. This negative out front of a log could technically come and go and become an exponent. Okay, your meme says that, right? Now, if you give cosine an exponent of negative 1, it takes it to the bottom, which is secant. And so my or option here is the, let's see, where do I want to put this? The natural log of the absolute value of secant x positive. Those are equivalent answers for the integral of tangent x. I'm showing you how to find them today. Do you have to do this method every time to find them? No. You can try and add this to your memory. Okay? I know the memories are overloaded right now, but, you know, obviously tangent one might be a little more important than some of the others we talked about today. Although I'll be honest, it's not one you see a lot either. But here's how you find it. You can also just memorize it. So this was minus the integral of tangent x. So I'm going to go with minus negative natural log of cosine x. Minus the negative, though, is plus a positive. I did. Why did I leave that space? Because no one had said plus d out loud yet.
I always look to see what spaces
I was debating. Oh, I could just say it and write it. And I was like, or I can just wait and see if someone says it. You know, and I don't know. You guys may have had it written on your paper. You may have forgotten at this point because we've done so many other things. So the gap gave me away, huh?
I said it last. Someone else's.
Sorry, you can go back and
Okay. Questions on that one? Example 3. Again, continuing to move up in the world, right? integral of tangent to the fourth x dx. Well, guesses? How should I break this up?
You can break it up into secant squared x minus 1 quantity squared. You won't have fancy stuff, but
I'm not sure I want to replace both of them. I'm trying to process how that would work, but then we'd end up with a secant to the fourth, and integrating secant to the fourth becomes a whole nother issue. You see what I'm saying? So, I get what you're saying. So, what Ross is noting is tangent to the fourth is tangent squared squared, right? Or how I'm going to write it is tangent squared times tangent squared. So, tangent squared x times tangent squared x times dx. Because, so if we do replace them both with secant squared x minus 1, we're then going to have to FOIL that, and we're going to have a secant to the fourth. That doesn't really make life easier, that makes life harder. So instead of replacing both, where am I going with this? Let's just replace one of the tangent squared. So I'm going to keep integral of tangent squared x times the other tangent squared x. I'm going to replace with secant squared x minus 1, still times dx. At this point, I'm going to suggest that we distribute. I'm going to go ahead and put it in two integrals like last time I did this. So integral of tangent squared x secant squared x dx minus the integral of tangent squared x dx. Okay. I'm loving the side notes today, sorry. Thoughts on how to deal with integral of tangent squared x secant squared x dx?
I'm spelling U substitution again.
I am going to go use substitution.
I know the derivative of secant is secant x. Secant x. So,
It does. So what do I want to make u?
Well, we don't know the derivative of tangent squared x.
It's not going to be an easy thing.
Yeah, so we should probably make a secant squared x.
No?
just secant
A
x.
secant,
No?
just tangent.
Just tangent. I was like, wait, which one did you just say?
There's 4 different options.
And here's the deal, guys. Okay. Look right here at the previous one. When we had tangent secant squared x, we made u tangent, and then the derivative was secant squared. Okay. And then we were integrating just a plain old u. Here, if I again make u tangent, the difference is instead of integrating a plain old u, I'm going to be integrating a u squared, which is still easy peasy compared to all the other stuff. Okay, so I'm going to again say u is tangent, and I'm making u tangent because I know the derivative of tangent is secant squared, and I see a secant squared there. I didn't make u tangent squared because the derivative of tangent squared would be 2 tangent x secant squared x, and then we've got a tangent that's unaccounted for. So if u is tangent, the derivative of u is secant squared x dx, right? And so when I integrate tangent squared, well, if u is tangent, then tangent squared is going to be u squared. If du is secant squared x dx, that matches up exactly. And so I'm integrating u squared. Add 1 to the power, divide by the new power, and we have, okay, I wrote 1/3 u cubed there, but yes, when you put it into your problem, it is 1/3 tangent cubed x minus integral of tangent squared x dx. Thoughts? We already did it. Can we cheat off of ourselves?
Yeah, absolutely.
The integral of tangent squared x dx, well, we did this in example 100.1. So by all means, cheat off of yourself. It's okay to cheat. That's the one person you can cheat off of, is yourself, okay? You're not going to get in trouble for that one. So now, it's going to be minus, if you look up here, the quantity tangent x minus x. If we're subtracting that, then we're going to say minus tangent x plus x, because we're subtracting the amount from example 1. And did you say what I think you said?
Still.
And plus c. Yeah, you had a free reminder of the plus c up there because example 1 showed the plus c.
So I think I have an inkling of what the shortcut may end up being.
In terms of the bottom part?
Yes.
Yeah, well, and a lot of them. So on the bottom part, we can go 2 different routes here. We can work them all out. Now, here's the deal. If we work them all out, it's going to be working them out pretty much identical to what we just did here, right? And there's nothing wrong with that. However, you can also look at connections, right? We know there's connections between tangent and cotangent, secant and cosecant. Think about the fact we know the derivative of tangent is secant squared, right? What's the derivative of cotangent? Negative cosecant squared. There's just that negative connection. Other than that, a lot of it is the same, right? What's the derivative of secant is, we even talked about that one today, I guess we haven't. The derivative of secant is, it doesn't matter. Secant x, tan x, tan x, secant x. So then what's the derivative of cosecant x?
Negative.
Negative cosecant cotangent.
It has a C.
Okay. So yeah, and that's those work very similarly. There's just usually with the cotangent cosecant, that's where the negative is. With the tangent secant, that's not usually the negative. So sorry, my daughter's messaging me. I can tell. It's been a week with her. I think that's a good way to put it. Okay. Example 4. The integral of cotangent squared x dx. Officially, if we're working this all out, what are you doing with cotangent squared x?
Changing it to cosecant squared x.
Right. Officially, you're replacing this with cosecant squared x minus 1. Right? That's your official, just like earlier, this is your official thing. Now, we can work this out with, I forget, did I use? No, I didn't even really use use on that one. Just, I broke it up. The other thing is I broke it up into 2, right? What would the integral of cosecant squared x be?
Negative cotangent x.
Negative cotangent x. Minus the integral of 1. You guys aren't going to let the plus c get away again. Okay. Notice if you compare back to example 1. Gosh, I keep hitting the wrong thing. It was tangent x minus x plus c. Tangent x just became negative cotangent x. Now, there is a part of this next one we have to work out. FYI. We can do part of it by Yes, you know, if you look, okay, so cotangent cubed. Look back up to tangent cubed. Well, the first part was a 1/2 tangent squared x. Like, I'm just looking at the answer right now. So the first part for tangent cubed was a 1/2 tangent squared x. What's that going to end up being down here? Cotangent, right? So instead of a 1/2 tangent squared x, I'm going to say 1/2 cotangent squared x, except it's going to have to be negative. Does that, right? Because we've always got that negative thing. Now, here's the deal. Minus. Last time. Okay, let me go back to the last screen. So we integrate that, got our 1/2 tangent squared x. Then we had to integrate tangent. And we got this natural log thing. What are we going to have to be integrating this time? Cotangent. So I'm going to be smart on this one. We're going to do the actual side note here. If we're trying to integrate cotangent, well, what do you know about cotangent? It is cosine x over sine x dx. Work through the u substitution with me. If I make u my denominator of sine x, what's the derivative of sine x? Cosine x dx. Now the difference is I don't have any negatives this time, do I? Okay. So we are really integrating, if u is sine, that's in the denominator, and then du is cosine x dx, so that's everything else. So you're really just integrating 1 over u du, which is natural log of u, but u is sine x. I don't really have a good or for that one. I think it's just usually natural log of sine x. Okay, those are good to be able to work out, right? Because tangent, that's one you might have. Cotangent, that's one you might have. Excuse me. So this one is going to end up being minus natural log of sine x. If you didn't already put it, plus c. Okay. Bottom one. First of all, notice we're not integrating tangent to the fourth again. There's a typo. It doesn't make sense to integrate tangent to the fourth again, does it?
Well, I thought that we would be doing the same problem, but this time you tell us an easier way.
Ah, sorry. I don't have anything for you there. Nice thought. That would be nice, but okay. So look up above because I don't really have any side notes on this. I'm just going to help you guys. Okay, so we're integrating cotangent to the fourth. The first part up above was 1/3 tangent cubed x. What's our first part here going to be? Negative 1/3 cotangent cubed x. And then our next part up above was minus tangent x plus x. But it was, if you recall, subtracting our answer to example 1. If we subtract our answer to example 4, it becomes plus cotangent x and plus x, because it would really be minus negative cotangent x and minus negative x. We definitely hit that human time of year. Are you guys okay with how I did that bottom section? Just kind of.
I'm going back through and writing in the work.
Okay. And that's, I mean, you can definitely take exactly the steps we did up above and do them down below, can't you? Okay, that's a definite. So, I don't know. I'm just looking at my notes from last year, and that's what I kind of did is, I don't know if we were short on time that day, or it may be one of those things in the past where I struggle to get through all the notes if we work the work out for everything. So, on the back, we have a similar technique in that we can do one of them and the other one we can kind of copycat. Had you guys already looked at the back?
I just glanced at it.
I just not doing it. Why? Like, it's like, it's a scam. They were all back here.
It's a scam. Okay. Some of these you already know. Integral of sine is negative cosine. Integral of cosine is sine. That's old news. Integral of tangent. Didn't we just do the work on the front to figure that out?
Mm-hmm.
Yeah, we did. Now, the or is not on there. Those are, so you might want to write that in. That's the acceptable or. We also just did the work of integral of cotangent. Don't look at the bottom two. That's these two examples. Okay. Now, and here's the question, though. How do we get to those bottom two answers? Okay, so the list is here so you have them. It's good to be familiar with them to know what kind of craziness to expect. With the exception of sine and cosine, integrals of your trig function are natural logs. Okay, and there's some memorization you could definitely do there. Now, example 7 when you're ready. Integrating secant x dx. Well, connection. I'm trying to think of a good connection here. What do you know about the derivative of secant x? Because when we go, we've got to talk like chain rule type stuff here. What do you know about the derivative of secant x? Tangent x, secant x, right? So there are a secant x and a tangent x involved. That connection didn't work exactly like I wanted it to. Okay. I don't have a good answer for how you're supposed to know what to multiply by here, but basically we are going to take this and we're going to multiply by a value of 1. Now, that value of 1 is going to be, it's a fraction, right? Same numerator, same denominator. And what we're going to use, and it'll make sense once we do it, is secant x plus tangent x. So we're going to multiply the numerator by secant x plus tangent x and the denominator by secant x plus tangent x. Okay, so it is secant plus tangent, not just secant tangent. So let's go ahead and multiply this and make this into one fraction. When we multiply by the secant x dx, this of course is just secant over 1. So on top, what is secant times secant plus tangent? Secant squared x plus secant x tangent x over my denominator of secant x plus tangent x, and this is dx. Okay, thoughts of where to go with this?
Well, it's a fraction. So in theory, we're gonna use U substitution
Okay.
in some way, right? And if you make the bottom U, that would work out decently for where the top would end up being
Oh, yeah.
du or x dx. So
So yeah, kind of following a step we did earlier, we have a fraction. If you let u be that denominator, u is secant x plus tangent x. Well, massive coincidence here, of course. When we go to find du, what is the derivative of secant x?
is equals the numerator.
Derivative of secant x is secant x tangent x plus, what's the derivative of tangent x? Secant squared x. And then, of course, we have a dx. Notice my du is my derivative just flip-flopped, right? You see it? Would have probably been easier to see if they were directly above each other, but you can see that, hopefully. So basically, we are integrating secant x plus tangent x, u in the bottom, secant x tangent x plus secant squared x dx. Well, that's everything else. So we are, like we've done several times today, just integrating 1 over u du. And what is the integral of 1 over u du? Natural log of u. And what's u?
Secant x plus tan x.
Secant x plus tan x. And then, of course, plus c.
U substitution.
Okay. Now, I don't know. Would that have been easy to see? I mean, you already knew it was going to end up being a natural log, so of course that, pushes you a little bit to think, okay, u is my denominator, but
I think
we've also done it some other times today,
I was
too.
gonna say, having done that and seen like the big fractions turn to that, I think that
Yeah.
helps.
Now, I'm not going to work 8 out unless you really want me to. But what I do want to talk about is what our 1 that we're going to multiply by would look like. Last time it was secant, we multiplied by secant plus tangent. This time,
Negative
Guesses?
secant minus cotangent.
just change one of them.
Cosine.
Just change the cotangent. So cosecant x minus cotangent x. Okay. And I would say guess what the answer is going to be, but you guys can cheat on me here. Natural log of cosecant x plus tangent x, and then of course plus c. Oh, okay, there is crud. Hold on. It is typo. Oh gosh,
Typo Wednesday.
something. Pre-cal has a bad lesson today too. Okay, so that's okay. I had to double check my notes here. This is supposed to be cosecant x minus cotangent x. So it's wrong down below too. So the integral of cosecant x dx is the natural log of cosecant x minus cotangent x dx. Better? Sorry. No, it's just one of those days we're in law of cosines and pre-calc, and there's several typos in that lesson. Several typos in this lesson. I'd forgotten about that when I caught the others earlier, but. Okay, your information is written off to the side. Number 5 becomes number 22 from 96, and skip 17.